In this lecture, let's take an example or numerical on current voltage characteristics of MOSFET. This is a very good example. So, in this example, it is given that the Kn of a MOSFET is 2 into 10 to the power minus 3 ampere per volt square. VGS is given as 2.5. VT is given as 0.7. We have to calculate the ID at exactly VDS equal to 1.8 volt. Now, whether we need to take the lambda or not in this particular question, so the answer is no. Lambda would be 0 in this particular case. Why? Because we are taking the value of ID exactly at VDS is equal to VGS minus VT, because VGS is given 2.5, VT is given 0.7. So what would be the VDS? VDS would be, what would be the VGS minus VT? It is 2.5 minus 0.7. That means exactly at 1.8. So VDS is also 1.8. That means we are talking about the condition VDS equal to VGS minus VT. And remember, at VGS minus VT, there is no lambda effect. Lambda effect is always there at some higher VDS value. Okay, so definitely here what equation we will use? We will use ID equal to Kn by 2 VGS minus VT naught whole square. So Kn is already given as 2 into 10 to the power 3 divided by 2, 2.5 minus 0.7, meaning the override voltage. So this is 1 into 10 to the minus 3 into 3.24. So the ID would be 3.24 milliampere. Now, to make this problem very interesting, let's do one thing. Now let's say in the same problem, ID is given. ID is one value of ID is given. Let's say at VDS equal to 2 volt. Let's say at VDS equal to 2 volt, ID is given, which is 3.3696 at the rate VDS equal to 2 volt. Now we have to find the lambda. Okay, so we have already find out the ID naught. So this value we have already find out, and we know that ID equal to what? ID equal to this ID naught into 1 plus lambda VDS at some higher value of VDS. This is the equation. That means we have a equation ID equal to ID naught 1 plus lambda VDS. What is ID naught? ID naught we have just calculated. It is at the pinch of voltage. That means exactly at VDS equal to VGS minus VT. So you know ID naught, you know ID. ID is already given at some higher value of VDS. You know VDS value, which is given as 2 volt. You have to find out only the lambda. Only one parameter is unknown in this particular equation. How to find out that? So we have already find this. ID set is equal to Kn by 2 VGS minus VT whole square 1 plus lambda VDS. Okay, so now this can be written as ID set at any value of VDS. This can be written as ID onset exactly at VGS equal to VDS equal to VGS minus VT 1 plus lambda VDS. So this ID is basically at VDS is greater than VGS minus VT naught, which is given at 2 volt. At 2 volt the value of this ID is given. However, this ID is exactly at VDS equal to VGS minus VT naught. So at 2 volt the ID is given as 3.3696. However, at 1 plus lambda into 2, that means at VDS equal to 2 volt, this ID value is given as VDS equal to 2 volt. So keep VDS equal to 2 and ID 0 meaning exactly at VDS equal to VGS minus VT naught, that we have already calculated, that comes out to be 3.24. So 1 plus 2 lambda equal to this. So 1 plus 2 lambda equal to 1.04, 2 lambda equal to 0.04. So lambda equal to 0.02 volt inverse. So thank you.